biopterin pathway. So this, remember, the MTHFR through the folate pathway feeds the methionine cycle to make SAMe, which then feeds the transsulfuration pathway to get rid of sulfates, sulfites, to make sure you're not making excess ammonia, to get rid of ammonia, to get rid of reactant oxygen species, reactive nitrogen species. That's your glutathione, that's your SOD, all those things. That also feeds the biopterin pathway. The biopterin pathway is where you make your neurotransmitters. Kind of important when you're talking about mood issues. Now I know nobody has mood issues here, but we still have to go over this. So, what does your mood come from? Well, does it come from things that you think about all day? Yeah, it does, right? But, so there is, when we talk about your brain, there's a chemical component, and that's what we're going to talk about with the genetics, and there's a neurological component, and that's what we talk about when I do a lecture on functional neurology. So when you're dealing with a Lyme patient, or a person with brain cancer, you have to rebuild these pathways. So when they have inflammation in the brain, or when you're talking about Alzheimer's or a dementia, so you're dealing with inflammation in the brain. So when I have inflammation in the brain, it's going to physically affect the neurological pathways. It's also going to chemically affect these metabolic pathways that we're going to talk about. So the neurological pathways are the physical neurons. So my prefrontal cortex has to connect with other parts of the brain. The prefrontal cortex is my part of the brain that makes me human. So this is where logic comes in. This is where I'm thinking. This is where I'm calculating. This is where speech comes in. My dog has a prefrontal cortex, but it's really little. So I can tell her to sit, and she can learn to sit because she does have a prefrontal cortex. But if another dog is running over there, her prefrontal cortex is not large enough to override what the midbrain is telling her. The archaeocortex, the deep part of the brain. That's your instinctual part of the brain. That functions outside of reason many times. She wants to obey. She loves me dearly, but her archaeocortex is sensing she needs to protect. So she's going to jump up and bark. And I have to go physically grab her and drag her back because her prefrontal cortex is too small. Her archaeocortex, her instinctual brain, is taking over. Yes?
It's true for some humans too.
Yes, it's true for some humans too. So as a human, we have a larger physical prefrontal cortex. But when we have inflammation in the brain, from a straight neurological pathway issue, it can block that communication from my prefrontal cortex to my midbrain. And I start doing things that are beyond reason. So is it true for patients? It was funny, but it is absolutely true for patients. So patients that have behavioral issues have typically a neurological problem, physically neurological problem, and it can be caused from inflammation, it can be caused by disuse, it can cause from everything. And they have a chemical problem, which we're going to talk about in a second. So neurological problem can happen because of inflammation, because of a chronic Lyme or something like that. But it can happen because of disuse. It can happen because the pathway was never created. That's what disciplining your child is. It's creating a neurological pathway. So if you don't discipline your child and tell them, no, you can't do that, how are they ever supposed to know that they can't do that? That's education. If my dog can learn not to go on the deck, my grandkid can learn not to go on the deck. Follow me? That's brain-based therapy. When you fire a pathway, that's brain-based therapy. When I learned calculus in high school, that was brain-based therapy. I fired a pathway that didn't exist. I didn't know what the teacher was talking about. Just what you're doing today. You didn't know anything like this. And if I'm doing a good job teaching you, oh, I get it, and you'll be relating it to things that you know about, now that pathway is starting to form. And I understand that pathway in your brain for genetics is just a gravel road right now. And maybe in me it's a 2-lane highway because I've been doing this a long time. But if you get into this and learn and learn and learn, no matter what it is you get into, I'm not asking you to get into this, it becomes a 2-lane highway and a 4-lane highway. And a job that you've done for years, and you're an expert at accounting, you're an expert at whatever you're an expert at it because you fire that pathway over and over and over and over. The more you use it, the more it builds, as long as you have the nutrients to build that pathway and you have everything else in place. But you get rid of the biochemistry, now all of a sudden you have issues with that pathway. So this person, they could remember things their whole life. They were an attorney. They remembered all these case things, and now they have this rapid onset dementia. Why? Well, the pathway was there, but they have some source of inflammation, maybe blowing out the pathway, or some sort of chemical imbalance, loss of chemistry. So the neurotransmitters aren't being created. Following me? So I liken it to a highway system. My frontal lobe's communication to my midbrain is a highway. I get Lyme disease, I get all this inflammation in my brain, or I get a concussion, I get inflammation in my brain, or whatever's causing it. It's like a flood. What's a flood do to a highway? It can wash it out. How am I going to rebuild it? You got to get rid of the flood waters. Just like one of my questions on my intake exam. Are you willing to make strict dietary changes? If you check no, you are not going to be my patient. If you won't get rid of gluten, you have an 8-year-old kid with ADD, ADHD, and they won't stop eating gluten and dairy, good luck with that one. You're never going to help them. You got this constant flood. You do brain-based therapy till your eyes turn green. But you got this constant flood. You're going to build up the pathway. It's like building a road back again, and the flood just continues. You never deal with the flood. You got to get the water down. Okay? The Biopterin pathway is the chemistry of that. So, when we look at this, this is the Biopterin pathway. Methyl tetrahydrofolate comes in here. It pushes this initial pathway. These are amino acids that feed the production of dopamine, norepinephrine, epinephrine, and serotonin. Those are your main neurotransmitters in your brain. So, the genes that we look at are the genes that hold those in place in your brain or degrade them. The first one is the MAOA gene that degrades serotonin. So this person has a double allele defect of that gene. They're going to have excess serotonin. If they are having a diet that is full of phenylalanine, tyrosine, and tryptophan, they're really going to push this pathway. They don't get rid of serotonin. Here's serotonin. They're making excess because they're eating all protein all day. So here's a 7-year-old kid with ADD, ADHD. All he'll eat is pizza and chicken nuggets. I can't get him to eat anything else. Okay, you're a crappy mother. No, I don't say that. I don't say that. I was just kidding. I was just kidding. Okay, so check your frontal lobe communication with that because you have to be a parent. Okay, but you cannot feed this kid all protein all day because all you're doing is feeding excess dopamine and excess serotonin. If they have defects in the COMP gene, in the MAO gene, you can't get rid of it. I feel sorry for the kid. Yeah. His brain is just roaring. He can't stop. He can't settle down. Dopamine is just like going crazy in this kid. Okay, and you could argue, well, the way this kid is made, he really shouldn't be sitting in school. And there's logic there. If you do have comp defects and mild defects, it's going to be very difficult to sit in school and behave and obey the teacher and look at the board and stop looking outside and stop looking at the squirrel. However, it is what it is, and we can do some chemical adjustments to help decrease dopamine and serotonin excess production. Follow me? So we're going to take this kid, this person has defects like that, and you're going to cut way back on protein. We have to look at the other genes too, because typically with these really bad cases with kids with ADD, ADHD, they have huge amounts of histamine. Huge amounts of gut inflammation equals brain inflammation. So you got to deal with the gut. Absolutely, you got to deal with the diet, or I said I wouldn't even take them. And then you have to look at this. Question back there.
I just wonder why the typical treatment for kids with ADD or ADHD then is to give them a medication and a jolt their dopamine levels up so high, like amphetamine or,
Okay, so why is the typical treatment is an upper? Okay, because kids' brains react differently to medication than adult brains do. And there is a metabolic pathway that I can't remember for that. But if you give a kid, for instance, if you give a kid fluoride, fluoride is going to be an upper for a child. It's going to be a downer for an adult. It's going to cause depression in adults. It's going to cause excitation in a child, in their brain.
but the amino acids wouldn't be different.
Right, not this. So this is how you make it or degrade it. But drugs have different effects on children. Good question. Does that make sense? Still with me? So it is, okay, let's say I'm not a child and I have some issues and I have, this is my gene profile. So I'm looking at mine and I have a double allele Mao defect and I have all these comp defects. No wonder I have so much anxiety. A lot of serotonin, a lot of dopamine in an adult who has a healthy frontal lobe is still going to have symptoms of anxiety, OCD, quick-tempered, ask your spouse, easily agitated, get angry easy, probably watching too much Fox News. But, I don't know. But, yeah, you probably are. You have to look at what you're feeding yourself emotionally too, right? And there's things from a spiritual standpoint that you have to do. But I have good spiritual people that are saying, I'm trying to hold every thought captive and I feel like I'm going crazy. You have to look at brain chemistry. So this is the way you can look at brain chemistry. And understand you can do a neurotransmitter assessment too and look at the levels of neurotransmitter. But remember, those are going to be a photograph of a moving train. So you almost have to do multiple pictures of that. Because that's going to change throughout the day upon demand. Following me? So from a chemical side, how would you intervene with a patient like this? You'd cut down on their proteins. And there's some specific nutrition that you could address as well. And we get into the next gene. Oh, this is the neurotransmitter profile that you could run as well. I also wrote a paper on comp and Mao pathway gene defects that talks about kind of what I just talked about. It's available on our website as well. This is the NOS gene right there that we talked about. I don't think I showed the slide when we talk about the NOS gene, but that's in the Biopterin pathway. And when I have defects in this gene, I have excess free or what's called uncoupled nitric oxide synthase. And that's what could bond to the excess superoxide ion when I have superoxide dismutase defects.